Thank you for joining us at the North Carolina Center for After School Programs. Today's lesson is called Mountains to the Sea in NC, in which we apply concepts of plate tectonics to geologic hazards and what's going on in North Carolina. Now there are three parts to this activity. The first part is the easiest part, and it's the most fun. So this is Laffy Taffy, and what we're going to do is use this to model three different types of stress that change and deform the Earth's crust. So you may have seen this as an activity with Milky Way candy bars, but I think that Milky Way candy bars can be a little bit messier, and with allergies, I think Laffy Taffy is somewhat easier. So the first thing that you need to know is there are three different types of stress. You've got compression, you've got tension, tearing apart, compression coming together, forming mountains, tension, tearing apart, forming oceans, and then you've got shear stress, which is sliding past. These three different types of stress make the landforms that you see. So we've got our Laffy Taffy, compression, pushing together. Can you see how that folded? That folding is how you get mountain building. So convergent plate boundaries where continents bang into each other and collide form mountains, like our Appalachian Mountains with folding. Now, the next type of stress that you're going to see is called shear stress. Shear stress is going sideways, and you can see it almost forms a letter S, doesn't it? And that letter S is the lateral movement around the edge of the rock that deforms it. And in places where you see shear stress, that's like the San Andreas Fault, where two plates are sliding past each other. In North Carolina, we have a little spot where the mountains formed and then the land kind of slumped a little bit down by Brevard, and then you get something called a shear zone, where you see shear stress in faults, and which are the remains of ancient earthquakes. The last type of stress that we see is tension, and tension is tearing apart. And you can see how that ripped in the middle. In the middle of the Atlantic Ocean, we have a giant ancient underground mountain chain, and actually it's rebuilding all the time, and it's spreading apart by tension, in which the ocean is tearing apart and new magma is coming up through the opening and forming new crust on the mid-ocean ridge. And that is one of the reasons why North America and Africa, when they collided together, they formed the Appalachian Mountains. And then after the Appalachian Mountains were formed, little bits of terrain or earth kind of slumped down, and then you had a shear zone that stretched around, and you can see some of that happening. And then the last one is the mid-ocean ridge. During the Triassic, when there were dinosaurs in North Carolina, the Atlantic Ocean started ripping and tearing apart. And those Triassic basins near Durham and the Dan River, for instance, are areas that go along with that seafloor spreading that's still going on now. And we're actually getting about 2 centimeters further away from Africa and Europe every year, which is about the rate of our fingernails growing. So anyway, that models those three different types of stresses that change the surface of the Earth. The next thing that we're going to do is we're going to look at a model of plate boundaries, and I've included for you in the lesson this little map. Now I put it on cardstock, and the reason why is because we're going to cut it and then we're going to submerge it in water. So for this activity, all you need is a pie plate, some cold water with blue food coloring in it, some hot water. Now, I don't ever heat my water in a microwave because it gets a hot spot in the center and it can burn you. So I just use hot water out of the tap, and I think that works fine. What we're going to do is we're going to be looking at the side of this pie plate, and we're going to watch how these very thin layers, which are going to simulate the continental and oceanic crust that's covering the outer edge of the earth, and then the liquid down below is going to represent the mantle, which is what all of the plates are moving on. Now the mantle is hot and it's got convection currents moving and circulating, and they rise and fall, and as they do that, the plates bust apart, move around, and that's how we get our mountains and our earthquakes and all of those types of things too. So the way to do this activity, first of all, have the kids cut this while you're getting the water. Make sure that they're cutting along the dark, bold edges, because that's the plate boundaries. If they get it wrong, it's not that big of a deal, but it will help them understand how the plates are moving. You do not have to put the entire map inside the pie plan. Sometimes it's nice just to put one or two of the continents in it so you can see it move a little bit better. Otherwise it gets too crowded. So the first thing we're going to do is put the cold water in. And I just go ahead and pour it in. I always put the cold water in because it's a safety thing. It's just easier. Now, the next one, put the map. And I'm going to put these two pieces, which actually, since I've used the cardstock, they're a little saturated, but they'll still float. And please note, they are floating, but they're not really moving around all that much, are they? And that's because there's not a lot of energy in the cold water. Now we're going to add the hot water. Now, if you want to do this with older kids, you can have them add a little bit with a dropping pipette. And when you do, you can see that the difference in the density will show up as a convection current. And if you put it in on the side, that little bit of red shows up against the blue. I'm not sure if it's showing up really well on here, but if you do it in person, you can definitely see it. And that starts circulating like a big pot of spaghetti. And when it does, when you add the warm water, you can really see that those convection currents start moving the continents apart. And you can see it picking up right now. And as the temperature increases, the motion of the plates increases, and they spin around and they move. In our activity, we have some interactive places where you can look on the internet at the different maps over geologic time. And you can see how that might actually impact the movement of the continents. You can see it moving really fast now, right? And so those convection currents are the source of the energy for plate tectonics, in which the plates are moving around and banging into each other and breaking apart. And that makes the physiographic provinces of North Carolina. It makes the mountains, the Piedmont, and the coastal plain, which is basically where all of the mountains that we used to have that were probably as tall as the Himalayas. Right now they're only about a little over 6,000 feet at the highest spot, but all of that dirt got eroded and carried out to the coastal plain by the rivers. So you can see how land changes over time and how our plate tectonics impact North Carolina. And also there's an extension for older children in graphing a section of I-40 from right about Mount Mitchell all the way to the ocean. And you can apply the concept of slope and distance to see how and where the breaks are in between the provinces. So I hope you have a great day and have fun with plate tectonics. Thank you.